Welcome to the fourth session on dual spaces, part of linear algebra. Today we are going to talk about the double dual and some other properties which we want to talk about, and what is called a natural pairing. And we are also going to prove something very interesting. W per perp is W. What is the meaning? We have to understand. Okay, we will do that. Okay. Yeah, please, whenever you want to send any email about my videos or anything, any request, please send to this email ID. Okay, right. So the first thing you want to talk about is that given a vector space V, okay, whether there exists enough supply of linear functionals. What does it mean? If I learn topology, you know there are what are called complete regular spaces, and you also know normal spaces. Here you have a set and a point x not in that, then you have a continuous function such that f equal to 1, 0 here and 1 there. And in normal space you have two closed sets A and B disjoint. Okay, then there is a continuous function f from the space which is 1 here and 0 here. That is, you can separate points, okay, points from a closed sets or two disjoint closed sets. Okay, if you are a BSc student, ignore this. Okay, so the answer is the thing. Suppose I have W, a proper vector subspace. Okay, and suppose I have an X which is in B but not in W. My question is, does there exist F from B to R if it's a field is F? Okay, so that, okay, f of W is 0 for every W in W, and f of x equal to 1. That's it. This must be, of course, linear. You understand the question? So something like, think of this. This is my B, this may be my W, and I have an X here. Then what do I want? I want a linear map from here, F to R. This is my R, so that it must be 0 here and 1 at this point. Okay, the proof is deceptively simple. Okay, answer is yes. Okay, let us prove it. Okay, now first thing I want you to notice is, since X is not in W, okay, the set W union X, okay, X is linearly independent. Okay, what does that mean? That means if I start with any basis B of W, then BW union X is linearly independent. Right? What does that mean? That means if you give me something like A1 W1 plus AN WN plus BW is 0, that should imply all my AKs are 0 and B is 0. Okay, where W1 W2 are and W linearly independent. Okay, why is that true? If B is 0, then that means A1 W1 plus AN WN is 0, and since these are all linearly independent, that means for every k, AK is 0. If B is not 0, then that means my minus BW is a1 w1 sorry bx plus an wn. Therefore my x is, since b is not 0, I can write it minus 1 by b, that is minus b inverse of a1 w1 plus an wn. That's an element of w, a contradiction. Is that clear? Yeah? Pause, review, proceed. The reason I went through the proof, you may think it's very obvious. The moment I said x is not in B, okay, then you may think this is obvious, but one has to understand what is the real meaning of that. Okay, what it means is, you give me any linear independent set of W, that along with x is still remains linear independent. That is, x cannot be written as a linear combination. That's what it means. But, and second thing is, I never assumed anything about dimension of V. It could be infinite also, and dimension of W can also be infinite. Okay, so I just have to make sure that you understand the concepts well. That's why I went through it. Please spend some time. Don't think it's very trivial. Okay, why we are wasting time on such things. Okay, now what I want to do is, therefore let us look at BW union X. This is a linearly independent set in V. Therefore there exists a basis B of V, so that, okay, BW is contained in B and X also belong to B. That is, singleton X union BW is contained in B. Okay, again this is true for infinite dimensional case. Okay, and by using Zorn's lemma one would have proved it, but if you don't want, assume dimension. Okay, for simplicity's sake you may assume dimension of V is finite. Then you know all these things. Okay, right. Now what do? Now I define a function f from, okay, from this set to B to R, namely f of x equal to 1 and f of, okay, let us say V equal to 0, V is in B minus x. Remember, B is the basis, right? Okay. Then extend this f linearly to all of V. What does that mean? You give me any vector x and V, sorry, V in V, then I can write it as V as some Ax plus B1 plus Bn Bn, where V1, V2, Vn and X, they are all in the basis B. A may be 0. Okay, I am not claiming A is not 0. Then I define f of V to be f of this, it has to be extended linearly. What does that mean? That is A into f of x plus B1 into f of V1 plus Bn into f of Vn. But this is 0, this is 0 and this is A. Right? Therefore f of Q to be A. Okay, so this f is linear, and so remember, x is not in BW, therefore BW is contained in B minus x. Therefore f of any y is 0, or f of w is 0 if w is in BW. Therefore f is 0 on w, and f of x is 1 by construction. Okay, so we have produced a linear function from where to where? V to R, so that f restricted to w is 0 and f of x is 1, and x is not in w and w is a proper subspace of V. Okay, pause, review, proceed. Okay, See, algebra may not deal with these things. When you want to go to function analysis, etc., you will need this kind of things. So I am giving in a sample of functional analysis here. But I am also going to use this result soon now. So how do I understand this? I say this as any vector space, non-zero vector space or vector space anyway, has an abundant supply of linear functions. Abundant meaning a lot of linear functions. What does that really mean? When do I say this set of linear functions abundant? Give me a vector subspace W and a vector X not in W, then they can be separated by means of a linear function. What do I mean by that? I have a linear function from the full space V to R so that f on W is 0 but f at X is 1. Okay, please understand this, go through it. Okay, we'll come to it again. Okay, now second thing is we want to talk about double dual. So I have a B, I have a B star. Okay, as I said, many times students already have problem with B star. Let me just make sure I am recording. Yes. Okay. Now what we do is this is a vector space, right? We know this is a vector space. Therefore, I can take its dual. We will simply denote by B double star. This is called double dual. Since B star is a vector space, this is also a vector space. Right? So next, if dimension of B is finite, let us say n, then we know it is a dimension of B star, and hence that should be dimension of B star double star, right? Because this dimension should be the same as the dimension, that means all of them are n. Okay? So we know that B and B double star are also isomorphic. If dimension B is finite, then this happens, therefore these are isomorphic. Is that okay? Okay. Now what we want to do is something very interesting. Okay. Let us look at for any x in V, let me denote x star as a linear map from V star to R by x star at F equal to f of x. You understand this? Yeah, I claim x star is a linear function on V star. Why is that? This is all very easy, but I will go through it. F star x plus g by definition f plus g at x. But how did I define vector addition of two linear functions? That is f of x plus g of x. But that is x star of f plus x star of g. So we have proved x star of f plus g is x star of f plus x star of g. Next thing is x star of some alpha f. But that's by definition alpha f acting on x. But that by definition is again this is by definition alpha into fx. But that is alpha into x star of f. You understand that? Yeah. So what I have done? X star of alpha f is alpha x star of f. Therefore, x star belongs to B double star. Pause, review, proceed. Okay. Now we want to say something about this mapping. Therefore, I have a map phi from B into B double star. How do I get it? Start with any x and map it to x star. Okay, x star therefore must be in B double star. Just keep repeating so that you become comfortable. X star should act on an element, that is x star must be a linear map from B star to R. That is, you are going to give me an f here. I have to tell you what is this. This is by definition f of x. Okay, I am just repeating. This is how you master it. Okay, just because you understood once, you cannot just like that keep going, then you may get confused. Okay, now notice that this is a vector space and this is a vector space and I have a map. So what is the next question I can ask? Is phi linear? right? The answer is yes. Let us look at it. Let us look at, suppose x and y are in V. Okay, then what is x star? So what is phi of x plus y? X plus y, that is going to be x plus y star. Okay, remember that's the definition. X goes to x star plus y star. But what I have to check? I want to check whether it is x star plus y star. Therefore that will be phi of x plus phi of y. You understand this? I have to check this thing. Okay, now let's look at, okay, what is x plus y star of f? That is going to be f of x plus y by definition. This is by definition, right? Remember, for any x, x star of f is f at that point. But f is linear. Okay, therefore it is fx plus fy, since f is linear. But this is x star of f plus x star of g. Y star of f. That, right? Therefore, for every f in V star, we have x plus y star, that is phi of x plus y equal to x star plus y star, which is phi x plus phi y. If you want, this is phi of x plus phi of y, that acting on f plus that acting on f. Therefore, this is phi of x plus y acting on f. Phi of x plus y acting on f is phi of x acting on f plus phi of y acting on f. You understand that? So we have shown that this is additive. Therefore, phi from V to V double star is additive homomorphism. And is it a scalar multiplication? Let us look at that. Phi of alpha x. Okay, so alpha is a real number. So let us look at what its action on here. That is f at alpha x. Okay, this is alpha x star of f, right? But alpha star of x is f at alpha x. But f is linear, therefore it is alpha fx. But that is equal to alpha into x star of f, that is alpha into phi of x, the whole thing acting on f, right? Therefore phi of alpha x equal to alpha times phi of x. Please note that if you are a BSc student, these things may be a little confusing. What is phi of alpha x or phi of x or phi of x plus y? They all belong to B double star. That means what? They are all phi of alpha x is a linear map from B star to R, and similarly phi of x is a linear map from B star to R. Phi of x plus y is a linear map from B star to R, right? So when I want to say phi of x plus y is phi of x plus phi of y, okay, what does it mean? See, phi of x is a linear map from B star to R. Phi of y is a linear map from B star to R. Okay, therefore I have a meaning of phi x plus phi y. I know this is a linear map from B star to R. We know this. Okay, then what do you want to say? This linear map is same as the linear map phi of x plus y from B star to R. So when are these two maps equal? They are equal if and only if for every f in V star I should have phi of x plus y acting on f should be equal to phi of x plus phi of y acting on f. I have to check this. If you notice, this is what we checked. This is by definition what? This is x plus y star acting on f. This is x star plus y star acting on f. Okay, now remember x star, y star and v double star. There, right? Therefore, what is the meaning? This is x star acting on f plus y star acting on f. Right? You understood that? but this is phi of x acting on f, phi of y acting on f, and this is phi of x plus y acting on f. So we proved it. Okay. Please bear with me. I want BSc students also to follow this, and as I said, the main problem with the dual space is already V is abstract vector space. Many students may have problem. Now we are looking at B star, which are functions from B to R. Then we are looking at V double star, which are functions from B star to R. So students get confused. So the only way is this kind of thing, keep on going back and try to understand every time what is the meaning of phi of x. Phi of x is an element of V double star. What does that mean? Phi of x should act on any f where f is in B star. Okay. Then what should I get? I should get a real number. How does phi of x acting on f look like? It is f of x, etc., etc. Right? Please go through it and don't get impatient. Okay. Just learning the definition alone is not enough. You should feel comfortable to work with it. That's why I'm spending time. Okay? Right. So now that we have shown that phi from B to V double star is linear, what is the next question we can ask? Whether it is 1, 1 or 2. Right? Let us do that now. Okay, I had already recorded without screen sharing, so I am doing that again. Is phi 1, 1. What does it mean? Phi is a map from B to V double star. I want to know, since this is already linear, this is proved. Therefore, to show phi is 1, 1, enough to show kernel of phi is 0. That is, if phi of x is 0 in V double star, then x is 0. This is what you want to prove. Right? Let us look at it. If phi of x is 0 as an element in V double star, what does it mean? Okay, remember the phi of x is therefore is a linear map from V star to R. Therefore, if you give me any f here, phi of x of f must be 0. Phi of x, it should act on f, it must be 0. Right? But what is phi of x at x? This by definition is x star of f. But that by definition fx. So I say fx is 0. Right? So I have phi of x is 0. That means if I want to know whether x is 0. Right? But what does that mean? Okay, for every f in V star, f of x must be 0. Okay? I want to know this implies x is 0. Please go through. Don't get confused. Let's suppose phi of x is 0 as a V double star. That means phi of x is 0 as a linear function from V star to R. That means when it operates on any linear function f in V star, okay, it is 0. But phi of x acting on f is same as x star acting on f, which is f of x. That means for every f in the dual space V star, f of x is 0. And then I want to claim that the vector x itself is 0. Okay, that is very obvious, because if x is not 0, then okay, there exists a basis V of V so that x is in P. That is, I am extending the singleton x to a basis of V. Right? Now define a linear function f from V to R. Now all of you know the trick. F of x equal to 1 x, okay, and f of b equal to 0 if b belong to b but b is not equal to x. Okay, define a linear function so that this. So you know how to do these things. Now we have done many times. Therefore f belong to V star. But what is f of x? It's 1. It's not equal to 0. It's a contradiction, right? Therefore, x must be 0. So what have we shown? If pi of x is 0, that means x star of f is 0 for all f and b star. And okay, this implies x is 0. Okay, that is, therefore pi is a 1-1 linear map from v to v double star. Okay, pause, review, proceed. So the next question I can ask whether when it's on to. In general, it need not be. Maybe false. But if dimension of V is finite, say n, then n is dimension of V, but that is also dimension of B star we have seen, and V double star is the dual of B star, which is of dimension B, therefore all are of dimension. Therefore my linear map phi, if V is finite dimensional, then okay, phi is from B to B double star is a 1-1 linear map of between two vector space of the same dimension. Therefore pi is a linear isomorphism. Okay, so recall, okay, if T is a linear map from B to W, dimension of V is dimension of W, then the following are equivalent. What are they? T is a linear isomorphism, T is 1-1 and 3T is on 2. So I use this fact. Okay, this map phi from V to V double star given by x going to x star is known as a natural isomorphism. Okay, this is a technical word, so I don't want to expand further, except notice that when I say dimension of V is finite, okay, then V is isomorphic to Rn. What I have to do is I have to choose a basis V1, V2, Vn of V and write any V as summation xk Vk, then map V to ordered n tuple x1, x2, xn. Okay, so to establish these are isomorphism, I have to choose a basis. Here I did not to define this linear map. Okay, here to define this linear map I did not need any basis. Okay, that is a basic idea. Try to understand as much as possible at this level. If you don't understand much, absolutely no problem. Okay, the next thing I want to talk about is so-called natural pairing. So I just now bombarded you with a very technical word, natural isomorphism, because I'm sure if you are with a student at a good institute or university, your teacher would have shown that so to you. Okay, it's a natural isomorphism. Okay, it does not use bases, etc. But to really understand, you need something like categories and functors to really appreciate what it does. There is a small exercise which I can give to explain that idea, but I don't want to, because at this time I don't think it's very important, okay, to understand that technical word in its full complete meaning. Okay, right. Now we will talk about the so-called natural pairing. That is also one word your teacher might use, that's why I'm also using it. Okay, but it's a very, very simple concept. We will not spend much time on that, but learn it well. Okay, it's very easy. Okay, now let's look at a map. I will call this map this is not an inner product, but I am using the same symbol. This is a map from B star to R. Okay, so you give me a B and F, okay, then it goes to B F. This by definition is F of B. Okay, it's not an inner product, because if it's an inner product it should be on the same vector space, that is, it should be a map from B cross B to R, and second, the vector spaces must be over field R or C. What I am going to do will be true for any field also. Okay, therefore this is not an inner product, but I am just using that symbol. If you want, you can also use it beta. Beta of VF is VF. I will say why I use beta. Okay, right? This because this map beta is bilinear. That is why I use the inner product symbol. You remember, inner product means V1 plus V2W is V1W plus V2W, and it's also in the second variable, it is the same thing, VW1 plus W2, same thing, and then CVW is C times VW, and these were real. Okay, and BCW is C times VW, etc., etc. Okay, this is a real inner product space. So something similar is true. That's what we want to show. So let us look at the first variable, V1 plus V2 of F. This by definition is, this is F of V1 plus V2. But what is V? V is a linear, therefore F of V1 plus F of V2. But this by definition is beta of V1F and beta of V2F. Okay, and similarly beta of V F plus G, this by definition F plus G acting on V. Now how did I define vector F and G are in V star? Every time you should go back. How did I define F plus G acting on V? I define it to be F of V plus G of V. But what is this? This is beta of Vf plus beta of Vg. So same thing, right? So similarly, scalar multiplication. There are two scalar multiplication, that is alpha V and alpha F also. So please check. So this map beta is called a natural pairing. Okay, I do not say anything more about this. This is enough. Okay, the next thing we want to talk about is, suppose V is a real inner product space and assume finite dimensional also. If W is a vector subspace, then we define the orthogonal complement W per, it is set of all V in V, so that okay, WV is 0 for every W in W. Okay, now W is this is a vector subspace of V, therefore I can talk about what is this orthogonal complement, which you call it WW per, and it is known, this is known, well known. Right? So, do you understand this? So, pause, review, proceed. So, question, is there an analog? So what is that now? That means B is any vector space over any field or over R, and there is no inner product, may not have any inner product. It is over any vector space, any field F, therefore I cannot talk about inner product. Even if the field F is R, it may not have inner product. Okay. Then for any w in V, I define what is w perp. What is w perp? Let us recall. It is set of linear function f in V star such that f of w is 0 for every w in W. Right? Now what is that I want to ask? Okay. Now notice that I have to make sense out of this question even. Why? Because w per what will be? It will be some functionals phi in V double star. You understand that? So that phi of f is 0 for every f in V star. Don't get confused. Just go back to the definition and understand this. Yeah? W perp is all f in the dual. Therefore, it should be all phi in the dual of V star. Yes, that is V double star, right? With that, therefore, what should happen? Phi of f must be 0 for every f in W perp. Sorry, for every f in W perp. You understand this? Okay. So, this equality has no meaning as of now. But we can give a meaning, that is, use if V is finite dimensional, then my phi from V to V double star, V double star, namely x going to x star, is a linear isomorphism. Right? Therefore, now I can ask w perp is set of all x star in V double star. So that, okay, what should happen? X star of f should be 0. This is true for every f. This is for every f in W perp. Do you understand this question? Because I am going this, so we will identify V double star with V. Therefore, anything is going to be x, but this is nothing other than fx. Therefore, I can as well say the set of all x in V so that f of x is 0 for all f in W perp. Please understand, these are the things which students actually have a lot of difficulty. Okay, go slow, understand this well. Do you understand this has no meaning? Because this should be a subset of V double star. Therefore, I have to look for phi, which is a linear function from V star to R. So that phi of f must be 0 for which f? For every f in W perp. Following? Okay. Therefore, this equality has no meaning because this is a subset of V double star. This is a subset of V. But if V is finite dimensional, I can identify V with V double star. Right? Yeah, I am still sharing the screen. Okay. Therefore, I can simply say, let us look at it. Therefore, any phi is of the form x star. Therefore, the condition is x star f is 0. Right? But what is x star f? X star f is fx. But x equal to x star I can identify. That's what we said, right? X going to x star, I can identify V with V double star. That therefore it is same as f of x is 0. So this is the question I want to ask. Okay, this is the definition. Therefore, we want to know whether this set is W. Please go through it. So we identify W double perp with the set of x in V so that fx equal to 0 for every f in W. Okay, this is a subset of V. Now I want to know whether this subset of V is same as W. Is the question clear? So pause, review, proceed. It's very important. understanding the question is very, very important. Okay. So the major problem with many students, even master's degree students, have problem with this. That when they come to W world, this kind of thing you keep on shifting, you should understand. So it's better to understand what is W double perp. Okay, that is a subset of B double star, but W is a subset of B. Therefore, saying these are equal has no meaning, right? If A is a subset of real numbers and B is a subset of some, let us say, set of all rational. If I say rational numbers, you will understand. Okay, let us say something like matrices. Okay, A equal to B has no meaning. You understand? So what we have to do is we want to identify these two sets are the same. B and B double star are the same provided dimension of B is finite. So we are going to use that. Then we understood B double perp, W to the power W perp. Okay, that is a subset of B. What is that subset? W to the power double perp. That is set of all x in V such that f of x is 0. Therefore, this is a subset of B. This is done by identifying B double star with B, and hence W to the perp double perp with some subset of B. Now the question is whether it is W. Is the question clear? Please think about it. Okay, just don't go through manipulating symbols. In a lecture, the teacher will hurriedly keep on writing things. You just accept, you try to memorize. Don't do that. Okay, now let's come back to this. So what do we know? So we had understood W perp is identified with set of all x in V such that fx is 0. Okay, so that for all f in W perp. The question is it W? Okay, first things first. Is there any relation between W perp and W? See, suppose x is in W. Suppose x is in W. Then I claim x belongs to W perp. Why? Because if x is in W, then what? When does x belong to W double perp? Notice that the only condition is fx must be 0. For which f? For f in W perp. You understand? Since x is in W and f is in W perp, certainly f of x is 0. This implies x is in W perp. Therefore, this is easy and done. Pause, review, proceed. So now I have to prove the next one. That is, I want to prove whether W perp is contained in W. Suppose not. Okay, what is W perp? We know this is already contained in W, therefore there exists. What does it mean? There exists here W, there exists x in W such that x is not in W perp. Is that clear? Let me just make sure. Yeah. So let x is in W perp. I want to know whether x is in W. Suppose not. So I was wrong here. That's why I have to think a little more carefully. Okay. That means x is not in W, right? Therefore, by our earlier result on abundance, of linear functionals. Okay, what we know? We know, okay, we know there exists an f in v star so that f restricted to w is 0 but f at x is 1. You understood that? Since f w, this means f belong to w perp, right? But f belong to w perp, but then f of x is equal to 1. That's a contradiction. What does it contradict? Because w perp is set of all x so that f of x is 0 for every f in w. Since I said x is in w perp and x is not in w, what I produce is I produce an element f in w perp, but that f of x is equal to 1. This contradicts. Okay, this implies x is not in w perp, a contradiction. Because if x is in w perp, what does it mean? For every f in w perp, fx must be 0, but my fx is not equal to 1. Therefore, we have proved w perp is contained in w. That is, w perp is equal to w. Please go through the argument carefully. I hope you enjoyed it. It's a little tough, okay? When the double dual comes, I know students have really problem. Every time, whenever something is there, ask yourself whether it is in V star or V double star, and what is the meaning. If it is in V star, it must be a map from V to R, which is linear. If it is V double star, it must be a map from V star to R. Okay, this kind of stopping every time whenever you write the symbol takes some time to understand. Usually you just manipulate the symbols, and in the blackboard also teacher quickly writes all those things because time is constrained. He cannot take as much time as I am doing now. Okay, so you just have to get confused, so take time. Okay, I hope you enjoyed this. Please review and you will certainly understand. It's all very easy. It's actually formal algebra. The only thing is that every time I have to pay special attention to the symbol, which space it means it belongs to, and what is the meaning that it belongs to that particular space. Learn this art, then you will never have a problem with dual spaces. In the next session, we will talk about adjoints and look at some examples. Okay, stay safe, stay tuned. We'll meet again.